Welcome from Munich, Europe, to the Asian crowd. It's a pleasure to give you a vision of how do we see the roadmap to B2G. If you switch to the next slide, I would very briefly hop into 4 topics, and we leave away the backup. You get the material later on and can see more details there. Why B2G? What is Mobility House behind that? How do we see the roadmaps? What did we do and experience there? What are, in our point of view, the system requirements, and what do we recommend? Mobility House actually was born 10 years ago with the vision of B2G, and I tell you, since 10 years we are fighting hard for it, but it took and takes much longer than we actually thought. So we started very early about approaching car manufacturers, learned that the vehicles are more complicated. Then we hopped a little bit into charging infrastructure to learn that the first connection point between car and grid and the energy market is the charging infrastructure. So we are a major player of charging infrastructure in Europe with 40,000 sold charging stations, but continuously we worked on B2G projects as well in Europe, the US recently with some bus projects, and very newly, Jack, we just approached Asia with a setup in Singapore. More details you will read in the press within the next days or weeks. If you switch to the next slide, a very brief recap. Why do we need V2G? And I think you can listen to a presentation of Volkswagen, Michael Joost, the chief of strategy there. Why do they shift to e-mobility? It's the same approach than Tesla, just on a larger scale. We need to have e-mobility to achieve the Paris Agreement and targets. And by including these batteries of electric vehicles, these absolutely unutilized assets of the battery, which is sitting around most of the time, which is never fully utilizing the cycles, as also been explained before, you could actually do with a battery. We need to use that investment and that capability to achieve our 2 or better 1.5 degree targets. And we also need it because otherwise we have to spend a lot of money in the grid. So actually we learned it's not so much money and we could afford it, but why don't we rather invest that money not in copper but in silicon and intelligence to control charging and discharging and save a lot of money, and give that money to the EV drivers and make EVs even more appreciating and cheaper than ICE cars and everything else. So by doing those 2 things, we also see that we improve the economics. However, a lot of people are talking about V2Gs. Various projects have been done. We have seen 2 already up and running in Korea and in Renault, which is a strong partner and also investor from us. We all know the great projects from Nuve in Denmark, which is one of the best examples for a fleet. And we have learned that from a project perspective, it's up and running, but how will it evolve? And if you go to the next slide, I try to show you that we are still quite a while away. Where we are currently at, we sold the first little bit over 1 million of electric vehicles worldwide. So depending on the countries, it's still a fraction of a couple %. So most of the customers, and this is what we experience in Europe, are still at the very basic. How should I charge? Where should I charge? How can I get it realized in my premises? All these basic stuff we never talk about. But that's where the EV buyers, mainly fleet operators, facility managers, are now struggling with. They still have issues with the car, with the vehicle. Just finished a call with Zalando Germany, where they say, oh, finally I have a transporter achieving the 300 kilometers, which I need for my last mile logistics. So we are still at the very beginning. And before we come to V2G, we learned there is one step in between, and which is absolutely underrepresented. It's V1G. Before we get bidirectional cars, we have much earlier an issue of control charging, not only behind the meter, which is the main issue for a facility manager because he can't afford or doesn't want to afford any additional grid extensions, paying money to the DSO or peaks, but also from a DSO perspective, because they don't want and can extend the grid. And imagine in these Asian megacities, if you need to extend the grid for a high-rise because you suddenly have 20 or 30% EVs in a high-rise parking. So you need to start with smart charging much earlier than with V2G, but it's a natural evolvement from smart charging to V2G. When do we see V2G? You all know there is, from a CCS basis, a major standard missing. That standard is the 15118-20. It's now in the absolutely finalization. It will go into the FDIS status in summer, and then normally companies start to develop and produce products on it, being it hardware manufacturers, being it software programmers. So as soon as we achieve that status, we can develop products until we see them in the market kind of in high quantities, until we see them integrated in a regulatory framework. I think we at least 2 to 3 years, and in some countries which are slow in regulation, and sorry, this is not the case in Asia most of the time. This is more a problem of Europe. It might be even 5 years if I look to Germany or longer. So one further word to V1G, so the second block, the green marked area, and if you switch one slide, and I want to give you an example before I hop into the V2G examples, is just that you get an impression how important controlled charging is. I showed you the exact figures of a fleet with 20 EVs, or actually it's not a fleet, it's corporate cars arriving at the company in the morning. And we are just talking, this is a parking place of 600 vehicles, and there are just 20 electric. Company cars, they arrive, you can see it on the time bar, between 6:30 and 10:30, so the marketing guys are most probably last in the office and need to charge. They just need to charge a couple of kilometers because they all live in an area between 15 and 70 kilometers away from the headquarters. If you want to charge, or if you would charge them without any control, you need a grid connection of 175 kilowatt, because all these cars start charging at the same time. And if you switch to the right side, you can easily, by V1G, reduce that towards 80%. So if you know, because the customers, or in that time the company car owners, say when they need to leave, you can schedule the charging over the whole day. So this is a very small and practical example of company cars in one parking garage of a headquarters of an automotive company. But you see, even that company would save already 70,000 euros in these 5 years, because they do not need to extend the grid and they do not need to pay demand charges, though this power peak you pay to the DSO. And different countries have different systems. So in the Netherlands, it would be cheaper because they are cheaper from the demand charges. In the UK, it would be even more expensive, or California. So this calculation you have to do for your country specific. But we see it with every fleet we currently equip. V1G is already a major important topic. Therefore, Mobility has also evolved a software stack which starts with V1G and can evolve subsequently to V2G. What have we done on the V2G side, and what did we see there? If you switch to the next slide. And I don't want to go into the details there. You can have a look later on, and please look at the YouTube video. It's really a nice documentation. There is one electric vehicle in Germany registered officially as a power plant. So this is a world premiere. This has been never done so far. Most of the projects have been realized under certain kind of created frame conditions. We said no, we want to show together with Nissan and the transmission grid operator Amprion that it also works as an official power plant. And if you go to the list of power plants in Germany, you will find there a Nissan Leaf /TMH power plant with 7 kilowatts. So I think it's the smallest power plant ever connected to the grid in Germany, officially approved for FCR, which is the most complicated product, also the best paid product, even if it's not so good paid anymore as it was 2 years ago. But we wanted to prove that a vehicle achieves that from a reaction timing, from a communication safety perspective, and it worked. We then did together, if you go to the next slide, that in a bigger setup, simulating a complete country. That was done together with Renault. We have heard them before, also with their activities in Korea, on the small and nice island in the middle of the Atlantic. It's Porto Santo, it's a Madeiran island. There we put 20 unidirectional, two bidirectional cars and one stationary storage based on, I think, 10 or 12 or 6 second life batteries. We included that in the complete energy system of that island. So they have some wind power there, they have some solar power there, they have a diesel generator, a small grid system. The island is 10 kilometers long. You can imagine that they have quite some challenges on the distances of the line with imbalances. And by applying these vehicles with a smart software stack, including the user's driver's perspective, we have been able to increase the renewable share, which is currently by 15% to 16%. So it's a real live application. It's running since June 2019. And it's running today. So people are using those vehicles today, plugging them in. And so by just 20 vehicles, we increased the renewable share by a percentage. So we are talking about 300 kilowatt hours of flexibility, or altogether around 150 kilowatts of flexibility if you look at that to power perspective. If we would go more to the limits, we could increase it to 20%. We did not want to do it because we still want to measure how customers' behavior is and do not want to go to the limits of discharging the battery or not charging it for the unidirectional cars. But you see on that real-time and real-life example how easily, with a very limited amount of vehicles, you can achieve a more resilient, more efficient, and more renewable energy system, as we explored that on the island. There's also a nice video. There's a link to click on the presentation. Look at it. It's still up and running and will be continued. More and more vehicles will come. They have altogether 2,000 vehicles, if I remember right, on the island. Around 1,000 of them are driving regularly. The others are more rental cars for tourists. So there's a lot of potential to make that island CO2 free, and this is also our intention. So if you go to the next slide, and to summarize it, what is important in our point of view for V2G? We realized out of those projects, you need to have a local control. You need to measure frequency locally. You need to react for behind the meter applications locally. So you need to have some intelligence locally. It does not work, and we had to change our complete software stack a couple of years ago out of a cloud in terms of safety reasons, resilience. Local and secure, because the whole energy system is kind of the backbone of the industry, of the country. It needs to run absolutely secure. We also realized that proprietary systems don't work. So whenever you do something, you need to stay independent. So we need to have an open standard there, because there are various customer needs, various charging station manufacturers, various backends, various DSOs, utilities. A proprietary system, in our point of view, will not work. You will never get an optimum out of a proprietary system. And it needs to be modular. I think I explained it. And this is also the CharIN perspective. We started with V1G. We will most probably see much more vehicle-to-home applications as already applicable in Japan than V2G applications in the beginning, and then end up with really huge aggregated amounts of vehicles controlled bidirectional. So it will scale subsequently, and the systems we apply need to be scalable at the end, because we want and we need millions of vehicles to control. Therefore, and I don't want to make too much advertisement, but if you go to the next slide, this is how we position ourselves as mobility house. Local, with the focus currently on fleets, not on vehicle to home, and scalable solution. You can have a look at it. And if I conclude with the next slide, what would be our recommendations? If you go to the next slide, please, is EV will not stop. So plan today with the growth. Either you are a fleet owner or a facility manager, a DSO or a utility, that will be your future. Plan it from a charging perspective, from a control perspective, from an energy perspective. That will be your future, and how can you utilize it? Don't get any lock-ins currently. Everybody is trying to say, yeah, this is the best, this is the best. Nobody knows exactly what is the best. And even if it's working for one country or one hardware, it might not be the next best for the next country or the next hardware or software. And whenever you plan, as EVs grow, kind of point one, they will be a major part of the energy future, of the grid and the energy future. Being it from the consumption side, being it from the load side, but also being it from a battery capacity side. So V2G, what we are planning about it, this kind of foresee that future, prepare for it, and especially prepare for it in steps. So this as a brief summary, how do we see and experience with all our projects? And I tell you, we have more than 3,000 car batteries without wheels under management, and apply various different software algorithms to them, earn money with them already today. Sometimes you also lose a little bit of money, which is not so appreciating because the markets are, from a regulatory point of view, not there where we want to have them. They are applied in all different kind of halls, soccer stadium like the Amsterdam Marina, or parking places. V2G works. We will earn money with it from different perspectives, from a grid operator, a utility, or car manufacturer perspective, and it will come. So let's prepare for it and find out the business models and the products for it. If you need any support of that, more than welcome. If you contact also for Asian interest, the Mobility House, soon also in Singapore.
Thank you, Marcus. Thank you for your insights. I think it gives a lot of food for thought, especially when we're focusing on regulatory framework and we're talking about avoiding to lock into certain technologies, and that standards are very important to make things happen. So good, thank you.
More than welcome, Jack. Pleasure.
So now we're going to the quick poll. And then Marcus, you will have to give us your insight on this outcome. Let's see. Here we go. Oh,
I'm not surprised at all. If you look the growth of stationary storage, which,
yes.
For example, in Germany we sold more than 100,000, close to 200,000 home storages already, all around 7 kilowatt hours.
Yes.
Because we have more than 1 million PV system on private houses. It makes a lot of sense. You see a strong growth of these storages in the US, especially California. You see them in Australia. Different reasons, so there it's more kind of a weaker grid. But the quality of battery and what you can do with batteries and how fast they react and how reliable they are and how long they last, as we also heard before, will show us much more applications than today.
Yeah, but specifically this question was towards companies. So do you think in the industry will be moving more and more towards fixed batteries?
Yes.
Or
yes.
Also,
you see it. So companies, they always are business case driven. If it's cheaper to have a battery than having production kind of fluctuations, and then they will buy a battery because a battery is good for that. And companies like the Eatons, AES, Teslas of this world are selling batteries significantly, and Tesla is mainly selling power packs to industrial and commercial customers. Even soccer stadiums, the FIFA allowed soccer stadiums now to use batteries as backup power. Before they had to invest in diesels. Now they saw that batteries are the better and faster backup power with much more power to provide than a diesel generator. So we see these shifts, and they are out of the regulatory framework. They start small, certainly. All disruptions always start in niches. But they are existing now. They're getting cheaper and cheaper, and will significantly grow. I think we will see a lot of batteries all over. and think back to your home appliances and count how many batteries you have in your house. I think you will add up with more than 50.
Okay, I'll have to count that.
Do so. No, don't do. But you can apply that principle also to a larger
power
scale.
plants. Yeah, you have to factory. Okay, good. All right, thank you, Marcus. We'll come back later. Now, Nick, it's your turn to defend your turf with DC charging at home.
Yep.
Go ahead.
Thank you very much, CharIN, and thank you all for dialing in to listen to us speak. Okay, we're on the first slide. Yeah, today I really want to just make a case for low power DC, and I know low power DC is not a very mainstream thing yet, but I think this is a space that presents a very big potential, but it's still very unexplored. Normally, when you talk about DC, you think fast charging, you think how you can quickly charge your car and the car can go on and do other things. But low power DC is a little bit different because that's really trying to make use of the EV downtime, and if we can use it a little bit more effectively than what we're doing right now, there are great potentials that presents itself, and that's really the whole idea that builds around low power DC. And of course, we want to look at how we can also optimize our existing EV charging infrastructure. Previous slide, please. If you can go back to the previous slide. Sorry, can you go back to the previous slide, please? No, previous slide.
A case for low power DC. That's your first slide.
In one, yeah. Yeah. So let me just before we jump into the slides, I just want to say a few words about Rectifier Technologies as a company, in case those of you who have never heard of us before. Rectifier Technologies is an Australian company, and we specialize in power electronics design and manufacturing. So in e-mobility in particular, we supply our power modules in high power chargers. But like I said, today I really want to park that aside a little bit, not because high power charging is not important. I think it's a very important space in our EV charging ecosystem. But low power DC has just got this potential that it carries, and I think it just cannot be ignored. So next slide, please. Thank you.
Next slide. Yep.
Okay, what you see here is our view of what an optimized EV charging infrastructure would look like sometime in the future. It's made up of 3 categories. It's got public, fleet, and private charging. Now, they're all going to be bidirectional capable, and they're all going to be made up of DC chargers only, and that's an important point to bear in mind. Public charging is obvious. It's required to enable long distance driving, and you typically see chargers around 50 to 350 kilowatts in this space. But don't be surprised to see even higher capacity ones, because they need to facilitate the long distance travel for larger vehicles like buses and trucks. So we should expect larger capacity, high power chargers in the future. Fleet charging, on the other hand, is still a very new space, but it will continue to grow as fleet gets electrified. As they get electrified and come into the market, you would expect to see a combination of slow and fast chargers in this space to facilitate the different types of fleet arrangements and applications. So that really depends on the type of application that you have, so that you would build a charging network that suits your particular application. But the space that I really want to focus on this afternoon is in private charging, because as of today, 80% of EV charging happens privately, and that includes home charging and also workplace charging. You don't really need a very high power charger in this space, because you would typically have about 4 hours or so to charge a car. So around about 11 kilowatts will be sufficient. This is the space that we feel low power DC will really be able to make an impact, and it's in this space in particular that we will be able to optimize, because right now this space is still dominated by AC chargers. And the reason for that is every electric vehicle right now that is supplied into the market is supplied with an onboard charger. Now look, onboard chargers I think were very important back when electric vehicles were first introduced, because the battery packs were so small. And the last thing you want is to find yourself in the middle of nowhere with no infrastructure, you've got a flat battery, and you're caught out in that situation where you just cannot get anywhere. So in that type of a situation, an onboard charger would serve as a convenient and comfortable safety net, all right? But our battery capacities have risen to a level that is no longer what it used to be when electric vehicles were first introduced. Next slide, please, as we talk about battery capacities. I want to look at some trends there. So this shows you here the trend of battery capacity since 2012. And since 2012, we've seen at least a 250% increase. And it looks like it's continuing to trend upwards. Today on a full charge, you get easily 350 kilometers, and your average daily commute is only about 65 to 70 Ks. So that means you can use your electric vehicle a few days before even having to, before recharging it. So very different to back when electric vehicles were first introduced, when people had this fear of running flat and not being able to find public infrastructure. In that situation, onboard chargers were very, very useful. But I want us to think about how applicable it is for us today as we see our battery capacities risen to a level that it is today. Next slide, please. Okay, I hope these pictures are quite self-explanatory, all right? Because when we carry around an onboard charger, we carry it everywhere we go in our electric vehicle, wouldn't it be like Mr. Baywatch here using one of these modern smartphones with one of those old phone receivers? It looks like there is no logical purpose to it. It looks unnecessary. He's either paid to do it or maybe just trying to make a fashion statement. And I think that question needs to be asked in our industry at this stage, considering what the battery capacity levels are today. All right, so this is really the main question that I want to pose to us as we think about where we sit in the whole EV charging infrastructure ecosystem. And I'm not talking about an onboard charger or taking it out just for the sake of taking it out. There are some obvious advantages for us to remove an onboard charger. Next slide, please. So these are some of the obvious advantages. And for the automakers, they would at least see the weight of the car come down, and so will the cost as they remove this significant component. I think what's interesting here is that it makes room for additional battery capacity, or if you want to put on new technology for driverless vehicles or something like that. Space in an electric vehicle is very premium. We know that real estate is just so precious, so that when you free up any of this space, you'd be able to use it for newer technology, for the advancements and the uptake of electric vehicles. And I think for the EV owners, they would certainly appreciate larger battery capacities because that gives them more electric miles. And I'm sure they won't complain if the price of EVs come down as well. So next slide to show you what rectifier technologies is currently working on. Next slide, please. Okay, this is our bidirectional charger, which we've given a name. It's called the Highbury DC Bidirectional. Previously, it was known as the home charger, but we've decided to give it a proper name anyway. It comes with two output power options, 7 kilowatts or 11 kilowatts, depending on the AC supply arrangement you've got. If you're charging your car, you'd expect to see a greater than 96% efficiency. If you're exporting power, then you'd expect to see a greater than 95% efficiency. This charger here is designed to have a very slim form factor. It's so that it doesn't protrude out too much from your wall, so that it can be very efficiently wall mounted and ideal for tight spaces. We're quite sure, in fact, very, very confident that this is the market's slimmest DC bidirectional charger that you can find, with a depth of only 119 millimeters. It's CCS compliant, although we have other versions as well. And you're welcome to talk to me about the other versions afterwards. It will also be OCPP compliant, and it will be supplied with an iOS or Android app for you to control the charger. Next slide, please, to just explain what features we will what bidirectional features we will release with the Hi-Vari. So the first bidirectional feature that we will release is the V2G, because we feel right now, with all the trials that are going on in the market, this is what everyone is trialing. There are so many different arrangements in different countries, so that you will need to work out the best type of setup. Everyone is still in trial mode, and V2G is what's most applicable in the market right now. If you've got any trials that you'd like to discuss hardware options, please feel free to reach out to me after this webinar as well. But for the CCS version, conservatively, we feel that we will be able to have something ready by Q3 2021. But that's also dependent on the release of the 15118-20 standards. I think the latest we've heard is that it will be released in October 2020. So we are eagerly waiting for its release. But like I said, if you are interested in other versions as well, please feel free to contact me after this webinar. Next slide, please. After we're done with the V2G, we will implement V2H. This is a very important feature because your electric vehicle stores about 3 to 4 days worth of energy, enough to power your home. And there is absolutely no reason why users or homeowners can't power their homes with the grid and with the car as well. Next slide, please. Because after we are done with the basic V2H implementation, we would also make islanding available. The idea here is so that users will be able to isolate their homes from the grid. There is now this access that you will be able to power your home directly from your electric vehicle, and it will be completely isolated from the grid. Your home will be completely isolated from the grid, and this will be particularly useful, I guess, for regions where grid stability is not as reliable. And this will be very applicable for them. And my final slide, please, and I'll end with this. So to me, I see this V2G movement as an opportunity for us to just rethink, recalibrate where we are in the entire electric vehicle charging ecosystem. We've made so much progress that maybe some of the things that might be a little bit dated and no longer required can be removed or replaced with something better, all right? And this opportunity doesn't come by often, and I think we can use V2G as we think about how since we're introducing new hardware anyway, it is an opportunity for us to think whether or not it's time for us to remove a component like the OBC or the onboard charger in an electric vehicle. You would see 4 mobile phones at the bottom left. The thing that they have in common is that they have got no headphone jack. But if you don't remember, let me just remind you that in 2016, when Apple first released the iPhone 7 without a headphone jack, the backlash that they received was just enormous. It was unbelievable. Everyone was complaining about the removal of something that they were so used to. But today, you don't even hear it as a problem anymore, because you've got wireless headphones that have flooded the market. You've got so many options. You're really spoiled for choice in this space here. And what's interesting as well is Apple and all the other manufacturers that followed them after that were able to increase the battery capacity by around 14% because of the removal of the headphone jack. I think this example here is very similar to what we need to think about for our industry in e-mobility as well, considering where we're at. in the whole, because we are at a battery level that is so much higher than what it was before when it was first introduced.
Right.
So was there a question?
Thank you. No, not yet. Nick, thank you very much. So what we want to see now is, what does the audience think about not having an onboard charger in the car? Does the audience think that the onboard charger will become a thing of the past in 10 years' time? So let's give it some time. In the meantime, I'm a little bit surprised to see that you would first come up with a V2G charger, and then later on with a V2H charger. I would have thought that V2H would be more easy to implement than V2G. What's your thought on that?
I guess
very short answer.
The thing is, the V2H bit is going to be present, but we feel right now the trials that people are considering are all going for the V2G, and we know that this is going to be a long game anyway. So we've decided that we'll go with the V2G first to satisfy that.
Here is your answer from the audience. So 50% think that onboard charger will disappear, 28% no, and then 16%. So this is actually the strongest reply we get between yes and no. In the past, we always had yes much stronger than the no's, but here the no's are a little bit pushing back. Your opinion on this?
Yes, I think this I'm actually a little bit surprised here, because I thought I mean, this is a response that I really like, but I was still quite surprised, because I know whenever there is a significant change like this, usually there is a little bit of resistance there. But this makes sense, right? This means that the market really understands as well that we are at a point now where the onboard charger is becoming more and more redundant.
Yeah. Okay, we have to talk to Renault later on about this point. Now we'll be having Vincent Schachter from NLX, and he's the focus speaker for the grid integration. So Vincent, if you're there, let us know.
Yes, I am.
Hi, Vincent.
Hello.
I'll leave it up to you. Hi. Let us know what is happening with ISO 15118, or eager to know.
Yeah, well, I will not. I'm not sure I can give you a full answer to this, but I will give you the perspective of the grid integration focus group on this. So I have two hats, right? NLX and then focus group speaker. Today, I will not speak at all about what NLX is doing on V2G, but we are in fact working quite in a quite focused manner on the topic, and this may be in some other occasion. For now, I'll represent my colleagues from the focus group. So next slide, please. Yes, so briefly, and thanks to the previous speakers for giving context and backdrop to V2G topics. So I will just be fairly pointed and technical here. What have we done and what are we doing? We've been working on CharIN's vision. That's the grid integration levels, for instance, which I will show in a moment, and also the dates that go with it. So when do we think the various technologies are going, what they are, and when we think they will come of age. The second thing we've been working on is indeed 15118-20, and particularly the V2G portion of it. And we have been working hard to show that it can implement the real life V2G use cases. Why is that important? Because V2G obviously is much more than communication between the charger and the car. It includes a number of other players, and only with the integrated view can the services be delivered. So we want to verify that actually 15118-20 can do that, and then make everybody aware that it can do that. We've also been working, again, same idea. V2G actually is a whole value chain, and we wanted to go beyond CharIN and start liaising with other players. And so, for instance, we are organizing a workshop with SmartEN, the Brussels Association focusing on smart grids regulation and policy in September, so that we can start working together and lobby jointly to help V2G develop. And our ongoing activities, so these are the things we recently achieved. Ongoing activities, I would just say, we need to get 15118-20 out, and we need the world to know that V2G over CCS is becoming a reality. That implies a number of actions, including testing, of course, and including our colleagues from car manufacturers, from OEMs, feeling safer that they will be working on standard, something that will become an industry norm. So next slide, please. Yes. So stepping back a bit, here I will be repeating, but in maybe slightly more overview type of way, what some of my colleagues have been talking about. For instance, Marcus Fent, who is also a key player in the grid integration work group. So why V2G? Because two reasons, really. And then there is a host of sub-reasons. One of them is it generates value. And by generating value, monetary value, economic value, it reduces the total cost of ownership of EVs. And therefore, it facilitates the transition to electric mobility. And so that value is generated in two ways, really. On the one hand, it's savings on the energy bill of the driver, or of the driver if it's at home, or the business if it's in a commercial setting, or the driver directly or indirectly if it's public charging infrastructure. That is saving. So you charge for less, or maybe you use your car to actually consume less electricity from the grid for your building, right, by powering the building with your car. Then you generate revenues from front of the meter energy services by providing grid services, frequency regulation, energy when energy is in high demand, etc. All of this at the end of the day is reduce the total cost of ownership. And then the second category of goals is to leverage those batteries and wheel to help the grid modernize itself. Now, we all know that there is a general trend, but this is a 20-year trend to decentralization, renewable, and digitalization. Having storage in cars is helping, and it's helping mostly as storage is in general by integrating renewable. It's helping with resilience of the power system, that's the backup story, and it's helping stabilize the grid day to day, and these are things like frequency regulation. By the way, people speak about V2G, but actually what we have in mind is the whole host of V2X, vehicle to home, vehicle to load, vehicle to grid, etc. And so those things are they're all intertwined, and it's a question of use cases. And this is why the use cases matter a lot. Two reasons, because it's a complex topic, and because it's a complex topic with a complex value chain and economic models that are not yet operational, there is no commercial V2G today. It's all pilots, right? And so we have to help this get born. And to help this get born, we have to bring clarity to the debate. And so the part of CharIN, of course, is on CCS. And so from CCS, and by looking at the overall system, we can try and bring clarity to the debate. So let's move on to the next slide, please. Okay. Well, one way we can bring clarity is through the vision of CharIN of vehicle grid integration. This vision, actually, CharIN divided the vehicle grid integration roadmap in 5 steps, actually. from grid compliant charging to level 4. These are not necessarily sequential. Some of these steps are being developed in parallel. And there is one misunderstanding that we are now trying to kill. On previous versions of that roadmap, there were dates on each of the columns, each of the levels, and those dates corresponded to CharIN's vision of full maturity of the offering. But of course, people confuse full maturity with start of the market, and these are very different things. So here you don't see the dates. But in terms of start of the market, for sure, bidirectional charging isn't starting in 2025. Like there was a question in the chat earlier on why we would wait so much. We won't. We believe V2G will start before that. And but full maturity is a different question. The second piece is we want to focus on one tweak on that vision, and that one tweak is the maturity of vehicle to grid. And so instead of saying that V2G could be some time off and then being vague about when it will get adopted, we would like to be able to say very soon that because of 15118-20, CCS is ready for V2G and is ready for V2G use cases in a more expressive, more powerful way than CHAdeMO was ready, of course, for V2G. CHAdeMO was a pioneer on V2G, but the expressiveness of the language that has been included in the draft releases of 15118-20 is quite different. It enables the V2G use cases in a much easier manner. And we would like to be able to verify that and explain it on use cases and then show it to the world. Next slide, please. Actually, that wasn't the next slide. There is an addition. There was another slide. No. Okay, so let's, if there wasn't, then let's get back one slide and I'll explain. Back one slide, please. So we've been working together between the communications focus group and the grid integration focus group on expressing, on verifying that with the snapshot, the current snapshot of -20 that is not yet official, we can express easily V2G use cases. And of course, in order to do this, we need to verify not only the communication between EV and EVSE, but also verify that this would work in a real use case that would include grid operators and local loads and intelligence in the cloud that manages this. So we have been focusing on two use cases that are, and between those two, they're not the only ones, but they're key and typical of the rest of the use cases. One behind the meter, which would be solar self-consumption, and the other one, which is frequency regulation. That is the historical use case where for the first time years ago in Denmark, V2G was shown to generate a lot of value. And so we have been working to show that using the new capabilities of -20, those use cases can be expressed. Once that work is finished, we will communicate on the results in a broad manner, and that's the next slide. We wish to have a solid, clear message on how CCS is enabling V2G for the players in a way that gives reassurance to players in the value chain that they're not taking a risk by relying on CCS in order to develop their products. And this is quite important because developing V2G, we find for grid players on the one hand, for OEMs, for EVSE manufacturers, is of course a risk, right? There are product development costs and product launch costs, And so it's important for all the players to feel on safe grounds regarding what they develop. And so it's a chicken and egg story between working on it to have a clear norm, a communication norm that can become standard on the one hand, and then which enables the use cases, and working on the use cases to give motivation for that standard. So we wish to break the chicken and egg situation and to send a clear message out. That was my message in a nutshell.
Thank you very much, Vincent. And we'll get back to you. Now we'll do one more poll session, which is, do you expect your grid operator to offer V2G services in 6 years' time? And we would like to check this answer compared to an answer earlier. So the numbers will come in very soon. So basically this question is the same question that was asked earlier at the very beginning. At the very beginning, we asked exactly the same question. And at that time, the answer to the yes answers was only 56%. And now we get 64%. The no's, similar, it was 20%, and now it's 19%. And the not sure's have diminished to 18%. So we have been able to convince some people that V2G can be really a service. Do you have any other input from your side, Vincent, on this output?
Yes. First, I think it's a pretty good score. If 1 hour of presentation is plus 8% conviction, rate, I think if we do a full workshop of 3 hours, we'll be there. So that's pretty good. My second point is 6 years is a very long time, and I can see grid operators working on how exactly they will deliver V2G services technically and from a regulatory perspective now in the next 2 years in the following countries. I see them in the UK, I see them in the Netherlands, and I even see them in Italy, and God knows that's not the most advanced country for grid services. So I think you all are right to be optimistic.
But you're mentioning that the grid operators are looking into V2G. I'm always surprised to see how little interest there is from the grid operators to be part of CharIN. Do you think that for the grid operators, V2G is a must-have, or is something like a good-to-have tool?
I think so. For now, they don't know for sure. And I would say, seen from the energy industry, V2G is a very hot topic. And like every very hot topic, some people, everybody is interested and has to take part in the debate because it's supposed to be a growth area, like stationary storage. On the other hand, grid operators are cautious, number one. Number two, grid operators by nature are cautious players, because they are in a highly regulated business and they make investments over long durations. Number three, if I were a grid operator, I would enter V2G if I can show if my regulator gives me a way to remunerate my V2G participation and investment. And number four, they're all negotiating for more control over the assets, which is an interesting, I would say, power struggle in the industry between grid operators, other energy players, OEM, on who controls the assets. So I would say, by and large, everybody's engaged, but the business model and who controls in the end, of course, is not frozen. And last, your point about grid operators not wanting to be part of CharIN, this is exactly why we're doing joint events now because I can tell you that grid operators and energy players in general are interested in vehicle grid integration, including V2G, but also smart charging. They all are now, and mostly they don't know what's happening on the other side, the same way that OEMs don't really know on average what's happening on the grid operator side. So there would be great benefits in sharing more between these two industries.
Okay, yeah. Thank you, Vincent. I want to ask Kijun Park, who is working for KEPCO, a grid operator. How much did the government push for this type of project to do V2G? Is that something that comes from the industry, or is the government also strongly involved in guiding this towards this V2G applications and V2G implementation?
So yeah. Could you please repeat again the question? I just
All right.
a little bit in front of the questions. Sorry.
So basically, I wanted to understand how does the process went in Korea about implementing these different test phases of V2G. Is that something where the government was deeply involved, or was it more KEPCO or the EV makers that demanded that this type of test and investment was being done?
Okay, I would say this way. Actually, the V2G technology is not commercialized yet, so the government only guide to the development of this technology for use of the renewable expansion, the penetration increase, and to use it as a distributed energy resource in power systems. So at the moment, in Korean government, they set a goal, like the phase of the V2G technology development by the year of like 2022. And then after that, the demonstration phase, and then and in that years, they wanted to make a sort of a business case or the market for this kind of a resource, and then finally government will guide the market and the power system to implement or participate by the users of electric vehicles of V2G enabled cars. So
yeah,
at this time, this stage, it's in the phase of technology development to demonstrate this is viable for the power system, and after that, there will be a sort of incentives and market for this technology. I think so.
When I'm looking at what Korea is doing at the moment with V2G, my feeling, at least in Asia, they're much more advanced than the other countries. What do you say about this?
Oh yeah, I think I agree that we actually developed this technology from 2015 in the laboratory, and then after that we work with the car manufacturers like Hyundai, Kia Motors to commercialize this technology, and so we are in the upfront, the frontmost part in the world, especially in the case of the CCS Taiwan plug.
Yeah.
And we at this time we are waiting for the standard, the finalization of the ISO 1115 standard to implement the the globally standard V2G technology to the commercialized vehicles and the chargers.
Yeah, yeah. So I can expect that your knowledge will be in high demand in the coming years. Then.
Well, we are taking the risk of that were developed business case of this V2G technology. We only hope to increase the penetration of renewables.
Yes.
Yeah.
Does anybody else want to give an input about the grid operators, how eager they are on V2G? Rolf, are you still in?
I'm here, yes.
Yeah, what is your feeling about the grid operators? I hear they're very conservative. I hear they will only go ahead if the regulatory framework is in place. So when I'm looking at what KEPCO is doing in Korea, it really moves pretty fast. I don't know how it is in the States, or how do you see it in Europe?
Yeah, I think definitely in the States, it depends on the actual state you're in, right? As you can imagine, many of the states there have, first of all, different attitudes towards both renewables, EVs, and things like that. But also have just different resources available. So the coastal states are certainly way more, advanced in many of these aspects. So California, for sure, is moving towards it. So the California Energy Commission, for instance, has a program that they're working through right now to enable vehicle-to-grid communication. So there are working groups that are almost done with the initial paperwork to create the business cases, the regulations, and so on and so forth. So they're working with several of the charge system operators, car manufacturers, and so on and so forth. So it's definitely happening. I think the utilities, and take it with a grain of salt. I don't have all the information there, but I think the utilities are sort of participating. Not all of them are necessarily driving it, but they're certainly participating and are interested in the outcome for sure. So I think that the critical piece is going to be the return of investment question also for the utilities there, as usual, right? But we definitely see California, Washington State, and so on. They have been working really hard on these systems. So I see it coming fairly quickly.
Yeah. Okay. Thank you, Marcus. I have one question for you, because you mentioned very often regulatory framework. How much percentage of your company's time is spent on this regulatory framework, or making sure that whatever your project is before it starts, how much time do you spend on making sure that it will get the go-ahead, or that you will be allowed to do what you want to do?
Actually, nothing anymore. We put some efforts in there last year. I think we really spent a man-year on explaining that to politicians, to associations, and there are some really good associations. Vincent also know them very good on a European level, because it exactly fits into the European Green Deal. They took it from there, but at the end we realized our German politics are kind of not the most active ones. So I trust much more in European kind of experts, which are not involved so much in industry politics. So we gave up to do that from a company level. that as we are engaged in CharIN, in the focus group grid integration, which is a really good platform, we got VDA behind it. There was a press release from VDA that they absolutely support V2G and that there's no harm to the battery if you do it properly. And we got Smart EN from a European perspective behind it. So I think there is something to be done. But you know, we have 700 local grid operators. They can be quite resistant.
Okay, good. Thank you.
You're welcome.
Thank you, Marcus. I have a question now for Kim, because you're coming from the Mr. Kim, are you there from Samsung Renault? Hello, Mr. Kim.
Okay.
The sound is very bad, so you will have to give a very short answer.
Yep.
Because you're coming from the same family as Nissan, which so you have some insight about CHAdeMO. So why is it that the focus for V2G was only with DC plug and not both AC and DC, like we are doing with CCS?
In our alliance, something different policy and Nissan and Renault.
Okay.
So yes, and the use case different than there and Renault and Nissan. So Renault is mainly focus target is AC. So Nissan have a target is the DC, but different our policy in the alliance.
Mm-hmm.
Yes. Not
Right,
a technical question, yeah.
Right. But do you think that it's a good strategy to have both AC and DC possibilities for V2G?
This is something and difficult question. So we think both is good strategy, both AC and DC.
Right.
Then,
so with CCS, CCS basically you don't need to choose.
Yeah.
You have both available.
Yeah.
That's good. All right. Good. Thank you.
Yes.
And then we have a question from the audience. It's related to why there are not so many DC chargers available on the market. What is stopping it? And then more specifically for two-wheelers. Nick, I think you're the best guy to talk about small DC chargers.
Yeah, I saw the question about two-wheelers. Well, for us, I don't know if I can really. Oh, sorry. Can I? Yeah, you can hear me now.
Yeah.
No, I don't know if I can really comment much on two-wheelers at this stage because the low-power DC product that we are designing really not targeted at two-wheelers. But we have had we have had interests in the past on supplying to this space in particular. I think at the moment, if I can just go back to the low power DC space that we are focusing on, just give me a second. I'm asked to share my webcam. Okay. All right. Yes. So if we just go back to the low power DC that we're talking about, it is really a space to sort of optimize what the current arrangement is. And I think the reason why it's not adopted as quickly is also because it's down to a cost thing, I feel, because at the moment every vehicle is still supplied with an onboard charger. So if you look at the cost of an onboard charger that's in the car, and then you've got to buy an external charger as well, then it won't make sense to buy two power conversion items. You've got one in the car and one outside, and that's the low power DC product, like our Highbury. But if the onboard charger is removed, then it makes complete economic sense, and the cost of ownership is expected to come down as well as a result.
Okay, so you would expect that two-wheeler maybe in the future will only be DC to lower the cost of the motorbike? Could that be a good option?
Yeah, very possible. Because the thing that we should add as well is that to have low power DC, it's really not that expensive. We can actually, one of the questions I got before was, can we create a portable DC charger, a small one, maybe 2 or 3 kilowatt, as an emergency charger? All right, people are using onboard chargers because of in case of an emergency. So we can actually think of an external portable DC charger that's 2 to 3 kilowatts, and that can be very easily produced.
Okay, good. I'm not sure if we can still continue because we're running out of time. We're already 20 minutes out of time. Is there anybody of the panel speakers who want to have a last word on V2G? Or any specific comment? V2G, the future is bright. I don't know. Oh,
well, can I say something?
Yeah, sure. Go ahead.
Well, okay, put it this way. I think for us, we feel that this, I said before in my ending slide, and I didn't quite get to make the final statement, in the sense that V2G, I think, is this movement where we're able to think about where we're at. But I think in order to move something into an optimized position, it really takes a leader. Every movement requires a leader, and I think in the examples I gave, Apple was that leader. And I think there are many Apples of our industry in e-mobility, and we require that leader in that position to be able to take us to that more optimized environment, infrastructure, ecosystem with the V2G movement.
Okay. Hi, Vincent.
Yeah, just a quick comment. I keep receiving questions from industry players on the energy side and also on the EVSE side on what CharIN is doing. There is very strong interest out there. And I think CharIN can have a leadership role in a specific part of the V2G space, but it's an enabling part. And so I think the future of V2G is bright, but it requires work.
Kijun, do you have one last sentence on V2G from your side?
Well, actually, this is now the stage of development and technology, and in a few years, we may need sort of a business case and the market and the aggregators for the V2G technology. So we are taking the risk of the early stage of this technology. Thank you thank you.
Right. Yeah. But the early bird gets the worm. So probably the ones that are investing now will get really the benefits later on.
Yep.
Rolf, do you have
maybe just really a message to any other utilities that are on the call and are listening and are not involved yet. I believe, coming from the traditional demand response side, that V2G can be such an enormous flexible resource to the grid that you should really all look into this.
Yeah, good. Marcus?
I can just agree with Rolf, and if even the EU paper is talking about flexibility, is including smart charging in a regulatory paper, I think the first principles are absolutely clear. So the matter is not does it come, the matter is when does it come, in which country, to what extent, and just prepare and make your business out of it.
Yeah. Okay, thank you. Vincent?
Yes.
As an NLX guy.
Oh, as we're taking V2G very seriously, but we believe there is a continuum between smart charging and V2G. These are not separate things. So smart charging is more mature commercially, And I would say 80% of the regulatory, technical, and operational work required for V2G, we're already getting practice on with smart charging. So it's a continuum. And I think it's a very strong message, because this is how we are going to market and getting feedback. So it's already happening in a way, using charging stations in a flexible manner.
Okay, thank you. Klaas, what is your last word on our event today?
Yeah, that is it. Just keep one sentence back to V2G. So we are speaking about business case and who is the first, but I see an obligation to concentrate on that for society, and that is more than having a debate on the connector creating the fourth standard, chow something or whatever. And so it's really a request to society and all our engineers to make that possible, because that is a significant impact on usage of renewables, and so we must do that. And if we don't do, I expect to have governmental bodies to regulate that, as they did for transport. And so I see not a question if, but just how quick can we go into that market. And final remarks to that, I learned again a lot by today, and thanks for all the panelists and participants to listen. So we had more than 170 participants. We lost some because we are 30 minutes over. So we do it better next time, but that was for our first CharIN Tuesday Asia, a great experience. And I'm looking forward to the next event and keep some of you back again. Thanks.
All right. Thank you very much to all the listeners. I do hope you had a good insight in this ISO 15008-20 standard. And also a very big thank you to all the speakers who took out the time out of their busy schedule to be present and also to make the presentation. So thank you very much. And please remember, you are all invited for the next event, which will take place on October 13. And then the third event will be on October 20. October 13, we will be talking about plug and charge. And October 20, we'll be talking more about what is happening in Asia. So many of the EV associations in Asia will be more involved and explain what is happening in their region. And since you're registered for the first event, automatically you're registered for the second and the third event. So again, thank you very much to everybody for coming in and listening to our V2G ISO 15118 event. Thank you.
Bye.
Bye-bye. Thank you.
Bye.
See you.
Bye.
Bye.
Thank you.
Bye.
Yeah.
Bye-bye.
Thank you.